Welcome to today's lesson. We were doing a question yesterday, so today is a continuation of yesterday's lesson. So I hope you are able to check out the video lecture in case you are not there. So the question that we were doing, we were supposed to get coefficient of variation, and I told you coefficient of variation is the formula is standard deviation over expected return. Standard deviation over expected return. So for investment S, the standard deviation was 9.3% divided by 8%. And for Q, 7.6 divided by 7.6% divided by 8%. So today I want us to learn something new, but it is also a subtopic of portfolio theory. Today we want to learn about covariance. Covariance is our next subtopic. So for covariance, the formula is also a bit long. Yes, Caroline? Hi? Correlation coefficient or variation. We have not learned about correlation coefficient, but we have learned about coefficient of variation. Okay, so there are some questions whereby you can be told to assess the risk. Assess the risk. Let me check here in my notes. Assess the risk, or maybe I know there is a question. I think that is very important if I Yeah, so you can be told, you can get a question like this, where you're supposed to assess the riskiness of securities. So here you have the returns for this one. They're calling this investment smooth, and the return for this other one. They are calling it Quincy. Can you see my screen? Hello, can you hear me? Hey. So I was telling you about assessing the risk. Assess the riskiness. So what you're going to do, you're going to calculate what we are calling the coefficient of variation. Of course, for you to calculate coefficient of variation, you must have standard deviation and expected return. So you'll calculate the expected return, the standard deviation, then using the formula, so you calculate the expected return for smooth and the expected return for Quincy, expected standard deviation for smooth and standard deviation for Quincy. So from there, you are supposed to make a conclusion. So let me give you the conclusion, and the conclusion will say the lower, maybe you can write, the lower the coefficient of variation, the lower the coefficient of variation, the less risky a security is. The lower the coefficient of variation, the less risky a security is. That means that you'll always choose between the two, the one that has the lower coefficient of variation, because the lower the coefficient of variation, the less risky a security is. I hope I've answered that. Yes? Carry on. Roslyn, tumekupoteza. Yes? Wow, wow, wow. So there is what we call expected return of each of individual security na expected return of portfolio. So kwa hii hesabu, we are going to use the expected return of individual security, ama kwa hesabu yote ya coefficient of variation, because you're supposed to compare between the two securities. Remember, we have you gotten the point? Exactly. Each. Pia standard deviation unatumia ya each. Yeah, I hope I've answered that as well. So I think we can proceed with covariance. Covariance is a bit straightforward. So for covariance, you'll just you copy paste the question again. You remember our question looked like this. So you just copy paste everything: state of economy, probability, returns of x and y. So you just copy paste everything, uweke hapa: state of economy, probability, the returns of x and y. From there, you're going to add what is called deviation from expected return, and you're also going to add product of deviation and probability. So deviations from expected return, deviation means difference. So the difference between the two, and here we are talking about x. You start with x. So the difference between return minus expected return. So for return of x, we have -8. That is what you are going to use. So the difference of the deviation, we are going to say -8, which is the return, minus the expected return. You see the formula here shows you RA minus ERA. RA stands for return minus the expected return. So the expected return, we had calculated it, not expected return of portfolio, but expected return of individual security, which in this case is 5%, but you're going to use 5. So what you basically do, you'll come here and say -8 minus 5, that is for a high growth. Normal growth, it will be 10 minus 5 is 5. 8 return minus the expected return 3. 5 minus 5 0. -4 minus 5 -9. That is the deviation from expected return. That is the deviation of x. Deviation for y, we take the return again minus the expected return for y. So the return in this case for y is 8%, but you're going to use 8. That is the return of the individual security. So what you are going to do, you're going to say 14 minus 8 equals to 6. -4 minus 8 is equals to -4 minus 8, -12. We have 6 minus 8, -2, 15. So these values, I hope you're seeing, it's return minus expected return. Return again, which is 20, minus the expected return, which is 12. That is how you get the deviation. Then we go to product of deviation and probability. The product. When you talk about product, we are talking about multiplication. So what you basically do, product of deviation and probability, meaning that this deviation and the probability, we are going to get the product. So we have 0.1 is our probability. The deviation of x is 13, -13, sorry, and the deviation for y is 6. So we are going to say 0.1 times negative 13 times 6 for us to get negative 7.8. The same thing, we are going to say 0.2 probability times the product of the deviation. 0.2 times 5 times negative 12. Then 0.4 times 3 times negative 2. Then 0.2 times 0 times 7. Then 0.1 times negative 9 times 12. Then you add everything. You're supposed to get the covariance of x and y as negative 33.0. That is what we call covariance. So I insist on having this column, two columns. One is deviation, the other one is product of deviation. For deviation, we are saying return minus expected return. For product of deviation, you take the probability times the deviations and then you add, you're supposed to get the covariance. Unless there is a question on covariance, so that you can go to correlation coefficient. Any clarification? So if there is no question, we can move to correlation coefficient. Correlation coefficient, here always know that you're being asked about the two securities or the two investments. So for correlation coefficient, and here we are talking about x and y, the formula is covariance of x and y. If you're writing this one, COV stands for covariance of x and y over standard deviation of x. This symbol is for standard deviation, and this other one is for standard deviation as well. So covariance of x and y over standard deviation of x and standard deviation of y. So covariance of x and y, in this case, we have it as negative 33. Divide by standard deviation of x is 5.8%. So standard deviation of x, we had calculated it here, 5.8, and standard deviation, you can see standard deviation of x, we have it as 5.8, and standard deviation of y, we have it as 7.6%. So what you basically do, negative 33 over 5.8% times 7.6%, the correlation coefficient is negative 0.75. Correlation coefficient is negative 0.75. And in case you're told to maybe say something about correlation coefficient, when you have a negative, securities x and y are negatively correlated. If an investor invests in the combination of these securities, he or she can reduce risk. So there is a reduction of risk when we have a negative correlation. The meaning of this is that negatively correlated investments is, for example, you invest in real estate and then you invest in maybe farming. You invest in shares and then you invest in maybe education. So we are saying negatively correlated investments, they reduce the risk The reason why the risk is reduced is because of the aspect of diversification. Instead of, we normally say, putting all your eggs in one basket, you do what? Instead, for example, of investing in farming, all your money you invest in farming, so you diversify. So the negatively correlated investments are those kinds of investments whereby you have diversified and it normally reduces the risk. But positively correlated is if you decide to do farming, maybe poultry, then you can also do farming in terms of maybe keeping goats. So that is positively correlated investments, which can be a bit riskier. Or if you buy shares, you put all your money in maybe Safaricom, or you put all your money in Equity Bank shares. So that means that in case of anything, that means that the risk will be very high. So unless there is a question about covariance and correlation coefficient, so if there is no question, we can go to, I think, the last aspect, and then we do a question. I'm hoping it's the last one. It's called portfolio risk. You can be told to calculate, the next subtopic is portfolio risk. You can be told calculate portfolio risk or variance of portfolio ama standard deviation of portfolio. Portfolio risk, variance. Ukiambiwa variance of portfolio, it's the same as portfolio risk ama standard deviation of portfolio. Of course, variance hautaweka square root. Standard deviation of portfolio ndo hukuwa na the square root aspect. Variance of portfolio. And by the way, I also want to say something. Sometimes you can be told, instead of standard deviation, you're told to calculate the variance of x. So for variance, ni hii square root hautaweka. So like here, the variance here is 58.2. But now when you get the square root, you'll have 7.6. So, but now I want us to look at variance of portfolio. Sasa hii si individual security, ni portfolio. I thought that I had opened that document, but ni kama sikufungua. Let me just open it. Variance of portfolio. Yeah, or portfolio risk. Sasa hii formula yake lazima mpendane na kukram. Portfolio expected return, portfolio risk. So let me show you, the formula is in the notes. What have I done? Let me stop presenting first. I opened the So acha tuteremke tutafute hapa. Yeah, portfolio standard deviation. It's also known as portfolio risk ama portfolio variance of portfolio. So the formula iko hapa in your notes. This is the formula. It's in slide 8. So the good thing is that it has been elaborated here. So formula ni alpha squared, or this italic A squared. Then there's this symbol. This one, it looks like a D. It's a symbol for standard deviation. And here, of course, we'll always have two securities, maybe A and B or R and S. So standard deviation of A. So this is the standard deviation of A. And then squared plus beta squared standard deviation of B squared. So it's not difficult. A standard deviation of A squared plus B beta squared standard deviation of beta squared plus 2YAB. This one looks like a Y, but it's a symbol for correlation coefficient of asset A and B. This is a symbol for correlation coefficient. So this one, so 2 times the correlation coefficient times alpha times beta times standard deviation of A and standard deviation of B. So that formula looks like that. So let me stop sharing. Then I go to our document. So that we look at a question, we apply that formula. So we have a question here. Musa Onyango has invested in a portfolio that comprises of 2 assets as shown below. So we have asset C and asset S. Then we have the amount invested. So sometimes haitakuja kama table venye umezoea na probability. So you have the amount invested, expected return, and the standard deviation. Here they are very good. They have given you the standard deviation. They have also given you correlation coefficient of asset C, of this asset, and asset S, which is 0.30. You're supposed to calculate portfolio expected return. Note that it is portfolio expected return. So what do you think we should do? Portfolio expected return. Anyone who can tell us? ama hii swali ikikuja utasema pass. So let me guide you. You see this amount invested. So sometimes unaletewa ikiwa percentage and it should add up to 100%. Na sometimes haujaletewa, imeletewa ikiwa money. So you can convert it to be either percentage ama probability venye utataka. So in this case, in the workings, so kama tumeinvest 4 million na hapa 6 million, total amount of money ni 10 million. So you add 4 million plus 6 million will give us 10 million. Then you say 4 million divided by 10 million so that you can be able to get the probability. Ndo hii hapa. So you take the 4 million divided by 10 million, you get 0.4. Ama you can convert it into percentage. So na hapa 6 million na 10 million 0.6. As long as unaona hii 0.4 plus 0.6 lazima I add up to 1 if you are using the decimal aspect. Alafu if you are using percentage itakuwa 40% plus 60%, so it should add up to 100%. So nakumbuka yesterday we just said that we use 30% and 70% ama 40% and 60. So sometimes hautaletewa ikiwa percentage. By the way, I've seen a question, I think we're going to look at it. A question similar to that. So from there, you're told to calculate portfolio expected return. So utakuja tu chukue 0.4 times the expected return. For portfolio, we normally use expected return. So 11% na hapa ni 25%. So utakuja useme 0.4 times 11%. Of course, 11% is 0.11 plus 0.60, which is 0.6 times 25%. Then you add. Whatever you get, 0.1940, convert it into percentage so that we have our portfolio expected return as 19.4%. That is how you do that. So, part 2 inasema we calculate portfolio risk. So portfolio risk, we use this Kalong formula. I think we'll shorten hapa. So we will use this one. So this symbol stands for standard deviation squared. A squared is the 0.4. Nakumbuka tulisema 4 million divided by 10 million. So that is the investment. So itakuwa 0.4 squared, that is our alpha, times standard deviation. So here we have C and S. Let me hide here. So itakuwa 0.4 squared. Standard deviation, the one that you are given is 15% squared, plus 0.6 squared times 20%, this one, squared, plus 2 times correlation tulipewa kama 0.3, and here I separated the correlation. You're not supposed to separate. So nimetumia 2 times alpha times beta. Alpha is 0.4, 0.6. Here, ensure that the correlation coefficient is just 1. So put atumia 0.3 and then times the standard deviation, 15% and 20%. Then you get the square root. So here I think I just wrote it. Sijawai change sijui kwa nini. but you're supposed, when you calculate all these, you're supposed to get your answer as 14.94%. That is how you calculate portfolio risk, ama ukiulizwa portfolio standard deviation ama portfolio variance, hautaweka square root, but mostly najua you can be asked about portfolio risk. That is the formula that you use to calculate portfolio risk. So unless there is a question or clarification, maybe we can do a question. So in this document, the lecturer's document, sijui kama kuna mtu akona swali kweli. Okay, there is no question. Let me go back to the presentation. So in this presentation, kuna maswali mingi sana hapa. So I know these notes, you have them. Actually, the last slide, here you're given state of economy, probability, rate of return. So hapo umepatiwa 3 securities. Then you're supposed to find each project expected rate of return. I can see you have a question. Yes, Mulobi? Fine, thank you. Oh, okay. Aya, hamna hizi. Acha nitume saa hii tu. Thank you for that. So let me share with you. It's called portfolio theory. So I was telling you, find, let me share with you so that you can check. I hope it's very close to me. Yes? Or from topic 3? Or 4, okay. So wacha hiyo I'll share after the lesson. So find each for each. So here I've been given 3 securities, kuna A, B na C. So tunaambiwa tutafute expected rate of return each. Kwa hivyo ni each and every one. So hiyo ni each. Variance ni wakati hakuna square root. Standard deviation, coefficient of variation. Swali ni mzuri. Compute the correlation coefficient between A and B. So correlation coefficient, nakumbuka tumesema correlation coefficient ni covariance over standard deviation ya A and B. So alafu part C nasema compute the expected return on a portfolio. Sasa hii ni on a portfolio if the firms invest equal wealth on each asset. So hapa ni expected return on a portfolio, then standard deviation of the portfolio. This question is very comprehensive and very nice. I'll share with you so that you can try it. Maybe you can try part A, B, B1, C and D. If you do this question, you've done the whole topic. You'll be able to do this question very well. But I want to show you some different aspects of how the question can be twisted. So let me show you how the question, maybe you can look at past papers. Zimeenda wapi? Let me see. Ziko hapa. So this is a question. MK Patel has an investment capital 1 million. He wishes to invest in 2 securities. I think we can do this. Expected portfolio return, correlation coefficient, na portfolio risk. Maybe we can do part 1. Portfolio risk you cannot do without standard deviation. What will we do? We can do part 1. Or maybe we can mark it. This one is for December 2019. So the good thing with this topic is that the syllabus has not changed. So the question will always be like this. So we have December 2019. We have question 2A. So let me see in this past paper how many questions we can do. Let's see, there is a question to do with portfolio. Yeah, there is also question 5. I think it's April 2019. Question 5A. So easy maswali unless you do them. This one is for strategic. Here. So kindly right now just focus on, especially for the theory, past papers will really help. I think if you do that, and if you also do last slide, wewe na portfolio mtakuwa same page. So maybe you can start with this question. And it's also good that you do this question. This one. Question 5. Assess the riskiness. here. So Mr. K. Patel has an investment capital is 1 million. He wishes to invest in two securities A and B in the following proportion. So 200,000 in security A and 800,000 in security B. The returns of these two securities depend on the state of economy as shown below. So we have boom, normal and recession. We have the probability and the returns here. So these ones are the returns for A and returns on B. So required, compute the expected portfolio return. Then part 2, determine the correlation coefficient between security A and B. Calculate portfolio risk. So I don't know how fast we can be and try and do this question. So who can tell us expected portfolio return? Where are we going to start from? Anyone who can tell us? Yes, Mulobi. Mm-hmm. 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 Okay. Thank you for that. So maybe you can get down to business because of time. So we are going to start. Ukiambiwa portfolio, lazima upate the expected return kwanza. So we can start with the expected return. So we are starting with expected return of A. Tunaanza na expected return of A. So utakuja useme, so you can write it downwards. Boom, normal. So for expected return, just say 0.4 times 18%. So you can write it, you can just do your calculations here. Then 0.5 times 14%. Then 0.1 times 12%. Then you come to expected return. Of B 0.4 times 24%, 0.5 times 22%, then 0.1 times 21%. So get the total, then you add. So what are you getting? As the expected return, let me see in the in call. Roslyn 21.24% for expected return of AMA. Oh yeah, but sawa. So yeah, expected return of A umepata. Exactly. $15.4. Alafu ya B ukapata 22.7. Yes. So ensure you're getting that. $15.4% and 22.7. Jared, naona umepata 12.7. Okay. So if you finish, we go to portfolio expected return. So we have 200,000 for security A and 800,000 for security B. So you are going to say 200,000 divided by 1 million. But 0.2. You can proceed, Roslyn. Tusikuchelewesha na ushamaliza. Yeah, Jared, I can see you have 22.7%. That's good. So what are the others getting? Portfolio expected return. Ensure that you get what Rosalind has, 21.24%. Yes, Jane, I can see you have 21.24%. It's correct. I also have the same. So let's go to correlation coefficient. Of course, for you can see you have 21.24%. That's correct. So let's proceed to part 2. Determine the correlation coefficient between security A and B. So correlation coefficient ni kumaanisha we must get the standard deviation of A. So tunaanza standard deviation. So it's good that you do vertically. Hivi vertically naona itakuwa mzuri, horizontally itakuchanganya. Standard deviation of A remember it's probability, then return minus expected return. So the return is 18, return of A. I hope you are still together. I can see time is moving very fast. So you're getting standard deviation of A as 5.1%. Who else is getting the same answer? So for standard deviation, you have said that you're taking 0.4 into bracket 18 minus 15.4 squared. Then next is 0.5, 14 minus 15.4 to bracket squared. Next is 0.1. It is return minus expected return. 12 minus 15.4 squared. So then you add. What are you getting? Kila mtu anapata yake. So let's start with the first part. 18 minus 15.4 squared times 0.4. What are you getting? Yes, 2.704. That is correct. 14 minus 15.4 squared times 0.5. Second one, normal. What are you getting? .98. Sawa, correct. Haya, twenda next. 12 minus 15.4 squared times 0.1. Tunapata ngapi? 1.156. Correct. Add zote. Yes, 1.156. Let's add 2.704 plus 0.98 plus 1.156. Tunapata ngapi total? Yes, 4.84 square root. Square root ya 4.84 ni ngapi? 2.2. That is the answer. So tuende standard deviation of B. Kwa hivyo hii tunamaliza saa hii. Standard deviation of B so you're starting with boom. I hope hatujapoteza mtu. Or in case you have a question you can ask. So 0.4, 24 minus 22.7. 0.5, 22 minus 22.7 squared. This is a house squared. Then next is 0.1, 21 minus 22.7 squared. So let me share what I have so far. So that you go to the next part. So but you can proceed with standard deviation. One point one. Hope you are getting the standard deviation as 1.1. Yeah, hiyo hesabu ikai kama itaisha leo. Correlation coefficient. So lazima tafute covariance, alafu tutafute standard deviation tuko nazo. So let me give you these as you can work it out. So get correlation coefficient, I'll mark, and then try and work out portfolio risk. So for portfolio risk, we are just applying this formula, this one, in your portfolio risk. So this is the, so I'll share with you these notes so that you can be able to calculate. So portfolio, what is it called? So correlation coefficient, the formula is here, covariance of x and y over standard deviation of x and standard deviation of y. So it means that you're going to calculate the covariance using this formula. I have shared the notes. Then calculate correlation coefficient. Yeah, and for portfolio risk. I think if you do that, hii topic utakuwa umemaliza. Because if you're told to assess the risk, we have said that you're going to assess the risk using coefficient of variation. Andrew, you're asking how we get in 22.7. Umeona? Also, Mary can see you have asked. I hope you've seen. So you can screenshot this question. Oh, that is good. You can screenshot this question. Actually, if you do this question and you also add, you can add coefficient of variation. We uko sawa topic. The whole topic is in your fingertips. Okay. So in case of anything, let me know. But that is it about that topic. If you do this question has everything. And I think there is also the question in the slide, the last question. But this one, kindly ensure that you've done it and you can share it so that I can mark it. So our next topic is called capital structure. We are going to have a class on Thursday and it will be an extended class. So right now what I'm trying to do, I'm trying to look for long questions so that for exam, you see this question is 10 marks. So if you can have question 1 10 marks, question 2 10 marks, question 3 10 marks, ama 15, ama 20, you'll be in a better position. So there is a topic called capital structure. I really hope that you will not miss. We'll have it on Thursday and it will be an extended lesson. Kama venye tume extend leo. Poleni sana. But we had to finish this topic. So also on Thursday, we will have an extended lesson and it is good that you be there because we will also do a question at the end of the lesson or before the lesson ends. So with those few remarks, I wish you all the best. Keep on revising. I'll be sending you more past papers. Right now it's a time to familiarize yourself with end of SEM exams, past papers. So we can meet tomorrow is on Wednesday. We're going to meet for management accounting. And then we meet on Thursday for capital structure. So with those few remarks, thank you so much and have a good night. Thank you.